slab, your robot should be able to avoid any obstacles that you put in its way, as well as staying within an arena that is taped off with black colored border. You can manipulate the parameters on the code blocks to make sure this chicken bot will turn left or right, how fast it moves, and even how much it turns. When programming, use a move block to start moving forward, then switch blocks to detect obstacles in the robot's path through the sensors. Make sure to loop the code so your robot continues to avoid obstacles.
This is an example of the horizontal orientation of the sensors. And this is an example of the vertical orientation. You can see that the robots in the video behave differently. Try to get your robot to stay within the boundaries as accurately as possible.
First, before coding, you need to design a flowchart to help you understand how to program your chicken bot to avoid collisions with obstacles. Here is an example of a flowchart. Follow steps A through E that I explained earlier to create your flowchart. It does not have to be the same as ours, just make sure you understand it.
Here are some tips for your flowchart. Include keywords so you can easily pick and move the code blocks when you start to code. This code includes a loop with switch statements nested inside of it. Familiarize yourself with the code blocks. And finally, play with the order of your flowchart. Try different things to see what you want to include in your code.
Now it's time to code. This is a general overview of what your code should look like. Do not feel pressured to follow the lab exactly. Experiment with the parameters and see what speed and turn radius works for you. Feel free to pause here and get a good plan of what you want to do for your code. Here is a zoomed in view of our example code.
Some hints for your code. When you're programming, set up the entire program inside a forever loop. Try using one loop and 3 different switch statements. This will make sure that your robot runs continuously. Set the distance for your ultrasonic sensors at 10 to 15 centimeters, but remember, not every robot is the same. If you're struggling, try creating a small portion of your code and then testing it on your chicken bot. Then you can continue to add on. Feel free to refer to the GradeCamp website for the lab manual if you're struggling.
Here is a bonus video of our chicken bots. They both have the same code and are trying to avoid each other without colliding. If you have another robot, try this. If not, try using household objects for your robot to avoid.